Hello and welcome to the Telegraph Studio and Business Reporter's Industry 4.0 campaign, hosted by the Telegraph Online. I'm Alistair Greener. If there's just one industry where innovation has a snowballing effect, then manufacturing bearings is the one. How could they be better? Well, let's find out with Jacob Turner from Bowman. Good morning.
Good morning.
Now, I see we've got some bearings here on the table. Could you tell us a little bit more about them and where we might actually see them in practical use?
What we've got here are particularly bearing cages. They're split bearings. So split bearings are used typically in very heavy industrial applications where you've got big machinery, or in boats and ships where you don't want to take the whole enormous engine and things apart. If you just need to change a bearing, the bearing comes apart. So they're a bit more complex than your standard skateboard bearings and a lot more industrial and heavy duty.
And what do we expect to get out of them? What's their purpose? What do we want from them?
You take your regular cruise liner, the prop shaft driving the propellers, you've got a series of very large ones of these bearings. They're absolutely crucial to the ship moving. The service life, how long those bearings last, is absolutely critical. Because if those bearings fail, if you have a problem with those bearings, that ship is not going anywhere. Every hour, every day, you've got that ship without working propellers. It's costing not pounds, it's not tens of pounds, it's thousands, hundreds of thousands of pounds. The longer these sort of components, bearings and so on last, it makes a massive difference to the viability of the whole vessel.
And that makes complete sense. You know, as you say, the associated cost of taking a vessel out of service is just enormous. So we've got different bearings here. So perhaps you could describe the difference between them.
What we have here is a traditionally machined brass cage. And they've been manufactured similar to this for a century. They've been around 100 years, this sort of bearing. But the problem with this is because it's limited by machining, it has to be made with pins. There's a limit to the number of rollers you can fit in. So you're very much limited by the manufacturing process. Whereas what we've now got is a bearing which has got significantly more rollers, which increases the load capacity by 30 or 40%, which is enormous. I mean, typically a 5% increase of load, you shout about in the bearing industry. 30 to 40% is revolutionary, frankly. And of course, that increases life significantly as well.
You say massively increased. How much are we talking about here in the life of that versus this one?
A bearing like this, 30 to 40% increase in load capacity, in the same application will give you 3 times, a 300% increase in life.
So the benefits are enormous. What's the technology behind that type of bearing that allows you to give all of these benefits?
It's a version of 3D printing, selective laser sintering, which allows us to use engineering grade polymers, plastics, nylons, and create shapes which are just not possible to make any other way. The complexity you can have inside this allows all these extra rollers and leads to that life. So it's not the material itself, it's the way you're able to use that material exactly as the design engineer would want to, rather than being restricted by machining or welding or turning, any of those kind of traditional subtractive manufacturing methods.
And all this makes absolute perfect sense. So it almost begs the question, with 3D printing being the big buzzword at the moment, everyone's talking about it, why are we not seeing that technology being proliferated throughout the industry more than we are?
Well, it's happening, but traditionally 3D printing has been understood as a prototype vehicle. You can take a complex form of something that looks, and you can make it very quickly. Relatively cheaply, you can make a complex shape and make it look nice. But what engineers are now realizing is you're not limited to using it as a prototype machine, a prototype process. You can make parts that are actually far superior than traditionally manufactured parts. And you can make them in volumes that were never possible before, and it suddenly becomes viable because you're not limited by that design. You can make impossible products.
And all this means that your role as an engineer is obviously changing. You're using different technologies in a very innovative world. So how is it changing your role? And what about your customers? They're seeing things differently as well.
From an engineering perspective, this is the dream. This is the dream thing, because you design for form and function. You're not constantly limited by, I have to be able to machine this, I have to be able to injection mold that. You can actually design for what's needed and the optimum product, rather than all these compromises because of the way you have to get there. I speak to other engineers every day, design engineers, who look at the technology and they look at what we've done with the bearings. They're impressed, and then they look at it and they say, but I'm not sure if we have a use for this kind of technology. And then you can see the mind going in within seconds. They say, except for this one thing, we've got a problem and I can't fix it. But if I could just design whatever I wanted and didn't have to worry about how it's being made, then it solves the problem. And suddenly there's this whole new toolkit available to design engineers, people developing products.
I mean, this is all very exciting, and especially to see how different it is. But one thing we know about innovation is it's changing all the time.
Yeah.
And, to use your word earlier on, almost exponentially.
Yeah.
So maybe give us a little bit of a glimpse into the future. What can we expect the future of this kind of technology to be, and what else is around the corner that we should be looking out for?
The technology has been around for a while, but what's happening all the time is the costs are being driven down. So the cost of the materials, the cost of the machinery, the speed of the machinery, so speed is coming down, costs are coming down. The materials available for these machines are improving almost every few months. There's new materials which all open more new opportunities and new potential. The more that happens, the more products become viable to look at manufacturing this way, and the more businesses and industries are able to benefit from the design freedom this offers.
Well, as you say, the benefits are clearly enormous, and it's fascinating finding out how this new technology is working and having such enormous benefits as well. Jacob Turner from Bowman, thank you very much indeed.
Thank you.